Is it now clear to all of you? Thus I am discussing the nature of the first graph. Yes.
Sir, in the spring example, as you said, you took the state as displacement. In some other systems, state won't be displacement.
Whatever. So that's why when we learn these analytical techniques, we do not specifically mention whether it's a position, velocity or acceleration.
Yes, sir. So
It is only with respect to a state and the rate of change.
So, sir, logically, we were able to make sense out of the spring example.
Hmm.
But in other systems where the state is not distance, how can we make sense out of the obvious x dot into x dot x, dx by dt, and to x is always negative is asymptotically stable.
For any of the practical systems which are asymptotically stable, that is, you can relate. That is, here at this moment, that is, we are first understanding, learning these techniques, and later, that is when I will give you the specific examples of the nonlinear system, then we can verify. Okay?
Sir?
Yes.
Sir, for the spring system, I think we should use displacement and double differentiation of displacement, sir, because displacement and velocity would be in the same direction.
See, that's why I said they are not exactly the same. It is just an analogy. But for the spring, what will happen? That is, now it's a scalar differential equation. That is, I'm drawing this graph with respect to x and x dot. But if you just talk about the completely the Duffin equation or the spring damper, everything is there. Then first you will have to decide that is which variable you will consider, because you can talk about x dot and x double dot. So that's why at this moment I didn't introduce that one. Okay? We will come to that. That is, even in case of a spring equation, that second order differential equation, that is how we can analyze that too we will run. At this moment, that is, I am restricting to only first order differential equation. Okay? Now, is the first graph clear? Now, what will be the situation for the second one? Here you see, that is, if somehow due to the motion of the system, suppose here in this direction x is negative, that is, it is increasing in the negative direction. Okay? But if it goes like that, then what will happen? See, x dot is increasing in the positive direction, right? Then what will happen? That is that the negative value of the x will decrease. Just you try to understand. Here, if x increases in the negative direction, but that causes a positive increment in the rate of change, then ultimately what will happen? The negative value of the x will go down.
Will it be something like this?
And that is, first if it goes like this, then after some time this